I'm here with Rajendra Mishra. He is the product manager for the real-time elemental analyzers, CNA. And I know you've been doing that since day one. Tell us about it. How long have you been with CNA?
Yes, the CNA was added to our portfolio in early 2010. So it's 13 years, right, from day one. I've been with this product, and I've seen it grow from very small, few tens of it, to few hundreds now, today worldwide.
And you're still involved?
Very much. Yeah.
Okay, that's nice to hear. So you know everything there is to know about CNA.
I live the CNA, yeah.
You live the CNA, good. So clinker production is the most energy-intensive step of cement manufacturing. Can you explain a little bit more about that?
Cement is actually limestone cooked at a very high temperature, 1,400 degrees or higher. And for cooking or for firing, you need fossil fuel most of the time. And limestone is calcium carbonate. Yeah. So it's like a double whammy. You are burning the fossil fuel, that emits carbon dioxide, and then you are also calcining the limestone. Yeah. So that emits carbon. So it's plenty of carbon dioxide that goes out in the environment in cement making, and especially the clinker. Yeah. So that's where it's very, very...
it's a challenge.
It's a challenge, yeah.
It's a challenge. So how come we're now discussing low-carbon cement production?
Yes, that's a fantastic idea that people are working on it, and it works. Reducing clinker. See, clinker you grind, it becomes cement. Yep. And using less clinker is the way to reduce carbon dioxide emission. So sort of a step towards green cement. Yeah. And how it is done is adding a lot of other material which is waste in some different industrial processes. Like steel making, you get slag. In power plants, you get fly ash. Then you get calcined clay. All this, and pozzolan. So these things, if you grind, supplement it along with clinker and grind it into cement, you're using less clinker. So less clinker is less carbon dioxide, and then
you get to the lower carbon. Yeah. That's how we can combine the two.
Yes.
Okay. So how is CNA different from the current methodologies used?
The CNA is elemental analyzer, bulk elemental analyzer. It analyzes the entire material passing on the conveyor belt, elemental-wise. It reports the oxides. And cement quality is all about its elemental composition. First of all, the CNA, with unique technology of generating neutrons electrically, not using any dangerous isotopes, is one good step. And then it's very safe. Another is that we have come up with an application, we have developed an application where we can analyze clinker and help our customers exactly put the right ratio and proportion of these material like slag, pozzolan, or calcined clay. So the right mixture of clinker and this material will give you the best quality cement without any compromise on quality.
In real time, I understand.
In real time, yes.
So that's the magic bit.
That's the magic, yes. Because lab analysis is always taking a small portion and relying on the analysis for the entire mass. Yes.
So where or how does CNA make low carbon cement production possible?
The CNA helps our customers measure in real time the entire quantity of clinker and the additions that the customer is making, like slag or flying ash, whatever. So the right mix is what is determined by the CNA, and its unique PFTNA technology, where there is no radioactive isotope, which is very dangerous to handle. So it's on-off neutron technology, and you get perfect composition monitored of your cement.
Can you zoom in a bit more on the advantages of PFTNA?
The major advantage of PFTNA is there is no dangerous radioactive isotopes like californium-252, and you can switch it off. That's the biggest advantage. So when the analyzer is off, it's safe to do maintenance around your conveyor belt, and people can easily move around. And if they accidentally even go closer to the analyzer in the field, because these are field instruments, it trips automatically. So there's zero possibility of any accident or radiation.
Safe. It's safe.
Absolutely, yeah.
And your favorite feature or your favorite aspect of CNA in general?
Oh, The most important aspect is its ability to maintain the calibration for long term, because the general radioactive isotope-based analyzers, they constantly lose intensity, so you need to recalibrate the analyzer. The PFTNA-based CNA, there's no need to recalibrate ever since you install it. The calibration remains robust, constant for the life of the instrument. Yeah.
Well, thank you, Rajendra, for this introduction in low-carbon cement and CNA.
Thank you.